Welcome back to this tutorial series. Sorry it's been so long since I've last posted. COVID has been quite interesting on my life, and I hope you guys are staying safe and healthy. Because it's been so long since the last tutorial, you guys might notice some small inconsistencies between this tutorial going forward and the ones previously. So please bear in mind that that's because it's been a very long time between the recording sessions. With that, today's video is going to be focused on the database. We're going to first talk about the database technology that we're going to be using, defining out the schema of the recipe book, choosing an ORM, and how we'll be maintaining the database schema, setting up a local environment, and then we'll start coding and building out our data access code. So what I have here opened is dbengine.com. It is a website to compare the popularity of the various database technologies. And you can just see just how many different types of databases there are. And it can be kind of overwhelming to try to choose the right one. You'll have to consider things like, do you want a relational, non-relational database? Do you want something in memory or to be saved on disk? Those kind of considerations, I would say, are something you would do when you become more advanced. For the time being, when focusing on tutorials and learning, try to choose something in terms of convenience over the specifics of the database technology. For example, if you're doing .NET development, you most likely want to stick with SQL Server. If you're doing Node.js development, you probably want to stick with MongoDB because most of those tutorials use that kind of database. And if you're learning PHP, you'll probably stick with MySQL. So like I said, because we are using .NET, specifically ASP.NET Core as our web server, we're going to be choosing SQL Server as our main database. Next, let's talk about our schema. So we're going to take a look at our existing application. In general, you won't have an application to reference. You'll maybe have a description, but I think it's helpful to just kind of sketch out something like a website if it helps you visualize the whole process. So let's go to our list view here, and we can see that we have two recipes here, which means that we need something to actually save this recipe. So in relational terms, we're going to need a recipe table. Just inspecting it, we know that we'll need a name, a description, and a logo. And remember, if you don't have a website when you're trying to solve your own problem, sketch something out just on pen and paper if it helps. Draw some boxes, squiggle some rough ideas, and call this name field, description field, logo field, just anything so that when you're designing out your data, you can refer back to this kind of quick sketch. Let's take a look inside of the data field itself and see what we have going on. And like I said, sketch out this as well if it helps you. So we can see here we have the name, description, and the image. But let's look at these fields here. So we have ingredients and we have instructions. So when I was designing this, I wanted to be able to keep track of the number of ingredients, and I wanted to have a quick instruction list. That's what I gathered when just looking at other websites that had recipe tracking capabilities. So let's expand upon the ingredients here. And we can see that we can actually have a lot of ingredients. That tells me that we're going to need a separate table to keep track of ingredients. Similar idea to instructions. We can have many instructions for one recipe. So we're going to also need a separate instruction to keep track. And it looks like these ingredients specifically will have a 3-column setup. We'll have the quantity, the unit, and the ingredient itself. And here for the instructions, it looks like we have some number tracking and the instruction itself. So let's take a look at the other one where I've actually added a few fields already. And we can see here for the pizza one, there is some data here. And what's interesting is that if I refresh the page over and over again, it looks like ingredients keeps track of it, which means that in the background of this, there is some ordinal position saved. And for the case of the instruction, the ordinal position is actually displayed. So in both cases, they'll need some kind of tracking for that. So let's go ahead and switch over to using Microsoft Whiteboard to actually sketch out our database. So we know that we mentioned that we're going to need somewhere to actually save the recipe. So let's do that. And let's kind of fill in the fields that we saw earlier that we needed. So we know we needed a name. We needed some kind of description. We needed some kind of logo or image that's saved. Okay. And then from the recipe, because we want to refer to it and be able to individually edit those fields, we're going to need some kind of primary key. So in this case, we're going to have an ID. And let's just say for sake of tracking things in the future, we want to keep track of when this was actually added. So we wanted some kind of created date. So let's go back here, make sure we have met all of our concerns, right? So we have logo, name, description, and then we'll have an ID so that when we click inside of this ID will be kept track of. Next, let's talk about the ingredients. We're going to want a table to keep track of all of those different ingredients. So let's draw another one here. Ingredients. And now let's think about what we want in this ingredients table. So we know that there is going to be quantity. We know we wanted the unit that that quantity was in, which in that case was in cups, pounds, tablespoons. And we wanted some kind of description for that quantity. So description. And now let's think about the fact that it kept track of where it was on that page. So every time you refreshed it, it knew that it was position 1 or position 2 based on the order you would add it. So if you already have 2 ingredients, you would then append that and then it would become the 3rd ingredient. So we want some kind of position. Since we don't really have a primary key yet, let's think of if we added a primary key like this. So we have ID. We still need to refer back to the recipe. So we'll need to be able to say that this one ingredient line is for one recipe. So we'll have to add a foreign key for that recipe, and then we'll kind of tie these together. And we know this is going to be a one recipe. We'll have many different ingredients. But now we can kind of think about the fact that for those given ingredients in that recipe, we're not really going to need a ID because each one of these positions here will be unique because they will increment as 1, 2, 3. And given the combination with recipe, so we'll go recipe ID with 1 and then recipe ID with 2, it will likely be that this is always guaranteed to be unique. So what we could do is a quick optimization on our end and say that we want to use these two as our opposite key. And that way we won't need an ID to refer to this table. At this point here, if things are getting a little too nuanced and too advanced, I would recommend leaving the primary key on and take a look at everything after we're done the database setup and writing the data access code and see if at any point you need to actually use the primary key. If you don't, then you can see clearly that you can just remove it. Let's quickly jump back to our ingredients to make sure that we have everything here. So we have the quantity, the unit, ingredients. We have a way to refer this back to the recipe, and we have a way to keep track of its position. Next, let's talk about the instructions. So we're just going to scoot this down a bit, make room, and start drawing our instructions. So instruction is going to be much simpler. We're going to just need a description. It looks like we'll need the position again. So let's write that down. The position and some kind of description. And once again, we'll need to be able to keep track of which instructions belong to the recipe. So we'll need that ID there. Instructions. And then once again, we'll need to refer them to each other. So we know that once again, it's going to be a one, and this is going to be a many. So this is what's known as a one-to-many relationship between the recipe and ingredients and recipe and instructions. Finally, we'll just specify that this again is the composite key, which will be used as the primary key. Next, let's talk about the ORM that we're going to be using. So ORM is the object relational mapper. And when we refer to that, we're usually referring to a specific technology that we're going to be using in order to access our database. The two ORM technologies we're going to be talking about is Dapper and Entity Framework. Dapper is from the creators of Stack Overflow, and Entity Framework is from Microsoft. Both of these technologies are incredibly useful to know, so I wouldn't choose sides in terms of only using Dapper or only using Entity Framework. Going over a very high level, Dapper is faster than Entity Framework and still faster than Entity Framework Core. Generally, Dapper is much more lightweight. You can get started very quickly just setting up a POCO class and writing some SQL queries, and you're up and running with your data access code. On the other hand, although Entity Framework is much more verbose and it'll take time in order to set up your properly according to the Entity Framework kind of way of doing it, you won't need to actually write any SQL queries. Most of your data access code will be in LINQ or Lambda expressions. You could obviously write stored procedures and SQL queries and use Entity Framework, but the preferred method is to go LINQ or Lambdas. Another huge benefit is that Entity Framework does come with a really feature-rich environment, and one of them is the migration tool that's built in. Once you've defined out your schema in Entity Framework, you can use their DB migration tools to keep track when your database schema changes. So in general, when would you choose Entity Framework versus Dapper? So I would typically choose Entity Framework in a situation where you're making a complex API specifically designed for a UI. It's also known as a BFF, a term from Sam Newman. This means a backend for a frontend. So those typical workflows usually include CRUD-based work. So create, read, update, and delete. Not necessarily entirely, but general flow of the data is CRUD-based. And I would choose Dapper in cases where I need to do a bunch of data processing. So things that would require a lot of joins, reading, updating, inserting, a bunch of those kind of things, I would consider using Dapper. Alternatively, I would use Dapper in specific situations where I want to prototype things. I find Dapper way faster in terms of prototyping and then eventually changing those prototype code to Entity Framework if it starts becoming a BFF, if it's very CRUD-based. So in this tutorial, I'm going to be actually choosing Dapper. Now, although the application we're making is very CRUD-based, I do like the fact that Dapper is very lightweight. I also find that there are other tutorials out there already that kind of demonstrates Entity Framework. And third, I don't think there's a lot of tutorials out there that actually shows you how to maintain your database schema with Dapper, such as Entity Framework has with its built-in tool. So I really want to highlight that in this tutorial as well. And the tool we'll be using is SSDT, or SQL Server Data Tool. This tool is developed by Microsoft, and I'll kind of dive into it to show you guys how you can maintain your schema with it. Next, let's set up our development environment. So what we want to do is to actually have a database that we can write data access code against. So what I have here in front of you is the Microsoft SQL Server downloads area. I'll put this in the description below. But what you can do here, if you choose, is to actually download the full feature SQL Server 2019 or the SQL Server Express. Go through the installation steps, and you'll have a database locally. The other approach you can take, which is my preferred approach now, is to set up your database through Docker. Now, obviously, you wouldn't do this in production, but for development, it's super easy to get someone else onboarded. So what I would recommend is definitely setting it up this way. And that way, for example, if you do need to go between versions of 2017 to 2019, or if 2021 is going to have a version, then you can just change your Docker image and you'll be updated to the latest version without having to uninstall the existing one, then reinstall the new one, and then having to cascade those changes throughout your organization. Now let's switch over to Visual Studio, and what we're going to be doing is updating the Docker Compose file to include that new SQL server that we want to create. Let's expand this, and what I'm going to do is I'm just going to copy over our SQL server. We give the SQL server a name, so you can name this whatever you want. If you have multiple ones, then you can name it specifically by the domain. The image we're going to be using is version 2019, and like I said, you can easily switch between 2017, 2019. If 2021 comes out, it's super quick to switch them. The next thing you'll need to do is accept the end user agreement, so that is required. And the other required thing you need to do is set the SA password. So this is a strong password that you'll need a uppercase, special character, numbers, and lower cases. So because it's a development database, I gave it password 123. The next thing you'll need to set is a volume drive. So this is very important so that if your image or your container gets corrupted and you need to rebuild it, your database and your tables are still intact. So by actually sharing that to your local system, if you have a bunch of recipes saved, your ingredients saved, you can kill that image and respin it up and your data is still intact. The last thing you'll want to set is your port. So the default port that SQL Server uses is 1433. And what I've done is I've mapped it to 5050, just some other port in case you do have an instance of SQL Server installed on your system. This way, there's no collisions, and you can have as many databases using as many different ports as you want. And finally, let's add some quality of life things here. So the first thing we want to add is depends on SQL Server. This means that SQL Server will build before the API server, and that's expected because we want to ensure that our database is ready so that our API can actually perform its data access. And the next thing we want to ensure is SQL Server is always running when Docker is running. So restart unless stopped will ensure that as soon as the Docker instance is running, your SQL container will be running. And this is important because you want to be able to query your database if you've made some changes. You want to be able to update your schema if you need to without always having to debug and run Docker Compose. And that's it. Now we should be able to run our container. So let's go open the container viewer. Let's open this up. And if we click run, we'll kind of see the system building, downloading the image, and then we'll have our SQL Server. So after a few moments, it should be up and running. I'm just going to pull this up so that you can see I have my API running. And if I check this for the ports, you can see this one is 5050. So this one is my instance of SQL Server running. And if I open SQL Server Management Studio, I should be able to gain access to it. SQL Server Management Studio is my preferred way of interacting with the database. You can also use the built-in one inside of Visual Studio if you wish. I will link in the description below where you can download the Management Studio. So with this, you click Open, Database Engine. You want to pass in the URL as host.docker.internal, and then you want to put a comma, and the port that we specified in our Docker Compose was port 5050. Next, you want to choose the authentication as SQL Server Authentication. The username is SA, and the password is the password you specify in the Docker Compose file. So this password right here. Once you do that, you click Connect, and it should connect you to this. If it doesn't work on your first try, give it a few minutes to actually start spinning up. Even though the container is running, the database engine might not have started yet. And if you're still having issues, what you want to do is you want to completely remove the container itself. And then you can also delete the data MSSQL folder and then restart from scratch. And like I said, if you don't have SQL Server Management Studio installed, it's not a big deal. You can always go click View, SQL Server Object Explorer, add a new connection, then type in this as your username. So you can type in host.docker.internal, 5050, SQL Server Authentication, username is SA, and your password is password 123. Click remember so you don't have to type it again. Click connect, and there you go. You'll have your connection to the database. Next, let's look at SQL Server Data Tool. So this is going to be a specific project type that's going to be allowed to us once you download this. And what we're going to do is we're going to use this tool to design our table, and we're going to use the data compare functionality to actually scaffold out the schema to our database that we've just created. So back inside Visual Studio, I'm going to open the source directory. I'm going to right-click Add New Project. I'm going to search for SQL Server, and you'll see SQL Server Database Project. Click Next. I'm going to place it inside of the source directory. So inside of here. And I'm going to just call this recipe book .main, because this will be our main database. You can name it whatever you want. So I'm going to click Create. Now that the project is created, I'm going to really quickly show you how to set up your table and also have a quick schema compare to actually scaffold out the schema to the database that we've just created. So the first thing you'll need to do is to create the schema. So I'm going to create that under DBO. This is the default one for SQL Server. And next we're going to define what we want to create. So we're going to want to create tables. And next we want to actually create tables. So you'll see that this is now added to the add area. So we click that. And what we want to do is to name our table. So this is going to be recipes. And I'm going to just quickly copy that over here. And you can see that it gets filled up here. So there's two ways that you can do this. You can either type it out here and it will be updated up there, or you can choose from the UI up here and it will be reflected down here as well. So what I have here is I've set my ID, title, description, logo, and created date. And then we've set the ID as the primary key. We've set a default value of the current date for the created date. The title is 50 characters, the description is 500 characters, and the logo has a max character length because it will contain the base 64 encoded image. Next, let's add the ingredients. So we're going to right-click on tables, add a new table. I'm going to paste in the word ingredients. And once again, I'm just going to copy and paste it here. And you can see it's reflected up there. So what we've done is we have our recipe ID, which is going to be the foreign key to recipes, the ordinal position so that we can keep the order when the ingredient loads, unit quantity, and ingredient name itself. So I decided to name this ingredient rather than description, just to be a little bit more specific. And let's just quickly expand this up here. You can see there's a bunch of constraints here. So this actually allows us to set the primary key and the foreign key. So the good thing about SQL Server Data Tools is you can actually use the UI to do a bunch of different things. So for example, if I want to set the composite key, I can right-click, remove the primary key, set the primary key as recipe ID, or I can set the composite if I want to set both of them as the primary key. And then same thing with the foreign key. Since I've already added it, I can actually just right-click, add a new one, and then it will kind of start scaffolding. So it kind of gives you a quick guideline of how you want to name things. I'm going to click away, and then you can see that it actually creates that for you, and it will actually have some kind of IntelliSense to say that column doesn't exist and the table name for to table doesn't exist and the to table column doesn't exist. So it'll be pretty nice in terms of changing your schema around. So for example, if recipe ID didn't exist inside of recipes, then it would give us a compilation error. So if the foreign key on this case, I specified like this. So the recipe ID is named that in the ingredients table, but in the recipes table, it's just called ID. So if I had a typo here where I'm saying I want that foreign key to be recipes ID, it will give us a compilation error and tell us that that is not a valid column. So very nice thing that SQL Server Data Tool has. Finally, let's set up the instructions. So let's go add a new table. Instructions. And what I'm going to do this time, I'm actually going to add each column so you guys can see. So for example, recipe ID, and we know the recipe ID is a unique identifier or GUID. I'm going to add the ordinal position, and that is going to be an integer. We're going to allow that to be not null. And then finally, we want to have the instruction. And we're going to say that's an var pair of, let's give it 250 characters. And we're not going to allow that to be null as well. So that's good. So now we have to fix our primary key. Let's switch that and then set as primary key. So now we have that as our primary key. And next we want to set our foreign key because we want to make sure that recipe ID exists in recipes. So right click here, add this, and we're going to say 2, and we're going to give it the recipes and then ID. Do that. And now it will scaffold out the name, and let's add the field we want to have as a foreign key. So we know in this table, we want recipe ID to be referenced to the recipes table. And we know that we want that to be on the ID column. And there we go. And that's it. That's the setup for this table. So now that we have our schema set up, one of the things we have to do, unfortunately, that this tool does not allow us to do is create a database. So let's go back to our SQL Server Management Studio. We'll go here, we'll right click, say new database. You can also script this out so that you can execute it as a SQL command. For now, I'm just going to say we created using the UI. The database name I want to make is recipe book. I'm going to say OK to all of the default settings. Now we have a empty database. So there's currently no tables available, just the default. So back inside Visual Studio, we're going to be adding something called a SQL compare. So we're going to right click on the project and click SQL compare here. And in this view, what we're going to be doing is defining the left and right side. So for example, the left side, I'm going to have it as our project. So whatever we've defined in here is going to be on left side. And the right side is going to be the destination that we want the schema to be compared with. So in this case, we're going to be pointing it to our Docker Compose setup database. So select target. And then we're going to select connection. And like before, we're going to say, let's go back here and copy our connection string. Set up as SQL Server authentication. Type in our password. Make sure we remember the password so that this can be reused again. And then we're going to choose our database here. Make sure the password is correct. And then the database that we've just created, we're going to select that, click connect, and then that should appear here and click OK. There are some random nuances that occur sometimes when using this tool. So sometimes you might want to scroll up, scroll down, and refresh this if it appears blank. So that's just kind of those weird little gotchas with this tool. But if everything looks like it's working, you can click compare. And it will take these tables here and compare it with my empty database. And it should tell me that I need to add 3 tables to the database. Now that that's done loading, you can see that it's telling us to add 3 tables. You'll also see modify and delete if there's any changes like that. And like I said, if this is coming up blank, make sure you just kind of drag this bottom part here up and down, and it'll kind of refresh the UI here. So let's click into one of these and see what it's trying to ask us to do. Because it's a plus, it's going to say that your left side, which is our project here, is going to be moved over to the right side, which is currently blank. So it means that it's going to add everything on left to right. So you can see the same thing for all of the other ones, that it's filled in on the left and empty on the right side. What you need to do is click this little update if you approve the changes, and click update and say yes. And then you can see that it's saying updating target. So just give that a moment and it should be done. Now that it's done, it'll say target update completed. If you click compare now, this should be blank and it'll say there's nothing to compare. Okay, you can see that this is completely blank. So let's try changing something really quick, just so we can see that it's working. So in the instructions, I'm just going to, let's say, change the name of this column, save that change. Make sure you save changes before the compare tool can pick it up. And then back in the compare tool, click compare. And now you'll see a change here. So if you click inside of this, you can see that it's trying to tell us that this column is renamed and this is what it currently is. So it will replace that with this. And make sure that you know exactly what you're doing here, because changes like this will try to delete this column and add a new column. So if you have data that you need to ensure it is actually going to be kept, you can rename the columns yourself, or you can write the scripts to do so accordingly. Let's go and undo that. Save there. And now we can see if we run the compare tool again, it should go back to being blank. Okay, perfect. Now let's go to SQL Server Management Studio. Here, when we had a blank set of tables, if we right click on the tables, click refresh, we should now see our tables, and all of these tables should be empty and ready to get started writing code in. There's one thing I forgot to mention, is that you should save your SQL compare so that you can quickly reuse it next time. So what you want to do is click save here. And within the project itself, you can just save this as your dev SQL compare. And then that way you can add the existing item. Now, whenever you want to compare, you can just quickly use the dev SQL compare, and it will compare your existing project to the recipe book database that you have. So this video is feeling a bit long. So what I'm going to do is I'm going to cut this right now, and I will include another part where we actually write the data access code. Thanks so much for watching, and sorry for the long wait between the last video and this video. I hope there wasn't too many continuity issues between that. And like always, if you learn anything, make sure you like and subscribe to the channel, and I will see you guys next time.